Hi, so welcome to live session 4. Before starting, let me know, am I audible properly? Is the screen visible to you? Am I audible properly? Is the
Yes,
screen visible
yes,
to you? Can you please
yes.
confirm? Okay. Okay, thank you, Mustaq. Okay. So, okay. So before starting today's session, let me know, do you have any question or any doubt from the previous session or possibly Sir also took some kind of YouTube session. So please let me know, do you have any question or doubt? If you have any question or doubt, please let me know from previous session or any concept related doubt. Please let me know. If you have any question or doubt, please let me know. Well, no problem. Okay, so you can ask the doubt later, okay? So let's start for today's session. Okay, before starting, one thing I want to mention something. Namely, in last session, one of you were asking where you can contact me in order to get the question solved, okay? So that day I told you that in NPTEL there is an announcement section. You can drop an email, but it happens that sometimes I did not get the email, or so that's the problem. So what I have done is the following. So you can open the chat box. I am sharing a link. It's my personal website link. So point is that so from last 2 or 3 days onward, I have started this. I post some kind of interesting and important things in the matrix as topology or related to mathematics. Okay, and so if you have any question or doubt, you can directly post the question there. That will come directly to me. Okay, so that I can directly reply to you. So that's the one point I want to mention. So you can check your chat box. I have sent one link. That's my personal link. You can drop your question in the link via the comment section. Okay. So that's what I want to mention. Okay. So, okay. So if you open the link, so there will be 4 questions regarding the distance. So yeah. So in last session, there was I have introduced some concept of distance between a point and a function. Well, let me write it down. Sorry, point and a set. 1 minute, please. So okay. So last session we have introduced a notion of distance. One more thing I should mention is that at any moment of time, if you feel that you have some doubt or you want to ask a question, please feel free to ask me without hesitation. You can stop me and ask a question, okay? Because this session are only for problem solving and doubt clearing. So please don't feel hesitate to ask question, okay? Okay. So in last session, we have introduced a concept between distance of a point and a set, correct? So suppose A is a subset of a metric space x comma d, and suppose x naught is some point of x. 1 minute, please. x naught is some point of x, then we have defined, then d of a comma x naught is defined to be infimum of d of a comma x naught, a belongs to a. So this is a definition that we saw in the last session. Okay. And also based on these definitions, so I mean, so look, so this definition only measures the distance of a point from a set. Okay. So now we want to extend this notion to the distance between a point, between a, sorry, between two subs. What happened? 1 minute, please. What is, okay. Between two, so now we want to extend this notion of a distance between a point and a set to the notion of a between two subsets capital X. Okay, so suppose A and B subset of X. Okay, now we are defining distance of A comma B to be infimum of DAB, where A belongs to A, B belongs to B. Okay. So in this way, we can define the distance between two subspace. That is, we are choosing the infimum of all possible distances between any two point of the subsets A and B. Okay. So this is the definition. So yeah, that's what I want to say here. Um, okay. So I mean, so basically, intuitively, what we are doing. Suppose we have two subsets A of X, and then we are taking the minimum of all possible distances, and that is we are defining it to be uh, defined to be the distance between those two subspace. Okay, so that is the definition. So now let's start with some problems. 1 minute, please. Okay, so before going to problems, let me know, do you have any question or doubt or anything you want to ask? Do you have any question or doubt or anything you would want to ask? Please don't hesitate. Okay. So it seems that till now everything is clear to you. Okay. So 1 minute. Okay. So hmm, okay. So first question is what? Okay. So after finishing this distance concepts, we shall start with the compactness and the topology. Okay. Last session, this some few questions left. That's why I was going through these questions. Okay, so let x belongs to real line. Okay, now question is calculate dq comma x. So that is you need to choose the distance between the point and that with respect to the set of rationals. So how we can approach, or you can start looking into last sessions notes. So there you must find some important fact regarding the distance, or without using those also you can directly try. So tell me, anybody, suppose x is a any real number, then what will be the distance from x to the set of rationals? Anybody please speak up. X is a set of ration is x a real number, and we need to calculate the distance of x from the set of rationals. So how are we gonna approach? The point is that if you are unable to figure out how to approach, please unmute yourself and tell me. Or if there is anything you want to ask, that's what you want to ask also. But please don't stay silent. If anybody have any idea how to approach this problem, please unmute yourself and tell the solution. If you are unable to understand how to approach, please tell. The point is that you can directly use the definition. In case if you directly use the definition, you need to understand what the actual definition is saying. At least you need to visualize that, okay? So just abstract definition will not help at all. So if you are able to solve, then also please tell me. If you are unable to figure out, then also please let me know. Okay, so let me write the solution. Okay, first of all, by definition, d of q comma x will be what? It will be infimum of d of rx, where r belongs to rationals. Okay, correct. Now we know that set of rationals is dense in real line. Okay, so this implies what? So this implies if we this implies if we take suppose we have x, okay, and we are choosing some ball, okay, and of some rational radius r, then by density it is possible to get an r prime which lies inside the ball. So in that case, what we can say the distance between r prime and x, this is of course distance between r and x, correct? Those that we can say at least visually. I mean, this is mathematically anyway. So this means what? This means that if dqx is non-zero, okay. So if dqx non-zero, suppose this is equal to r naught, okay. Then, so of course we can choose some point. We can choose the fixed point x, and we can consider a small radius of r naught, and there we will be able to find an r prime such that distance between r prime comma x is less than d of rx, correct? And that is contradicting the minimality of this gq of the r naught. Okay, so this implies what? This implies that distance between the point and x equal to 0. So this is what it is. Do you understand the argument? Please let me know. Okay, let me repeat the argument first. 1 minute, please. Okay, so so let me repeat the argument first. So, 1 minute. Hmm. Suppose x belongs to real line. Okay, now we need to calculate d of qx. Okay, now d of qx is nothing but infimum of d of rx, where r is a rational number. Okay, now we know that q closure, and we know that q is dense in r. So, okay, since q is dense in r, so if we take, if we consider x, and if we consider then, if we consider an open ball of rational radius r, then inside the open ball we will able to get an r prime which is rational also, such that, I mean, so we'll get a ball point inside the ball. So of course d of r prime comma x, that will be less than equal to d of rx. So this observation tells what? This observation tells that if this infimum is non-zero, suppose the infimum is r or not, okay, and then we are choosing an radius of ball r naught, and then inside the radius of ball r naught we shall able to locate an rational numbers r prime inside the ball of radius r naught, such, such that this holds d of r prime comma x less than d of rx, because r prime inside the ball. But this is the contradiction. Why? Because this, if this equation holds and r naught is the minimum of distances of the point from the set of rationals, so this inequality, um, disrespects the give hypothesis. This inequality disrespects the given fact that r naught is the minimum or infimum of all distances. That's why d of q comma x has to be equal to 0. So this is the full argument. Are you able to understand? Let me know.
Yes, sir.
Okay, thank you. Okay, so, and so this is one way of solving. Of course, it is direct way, but but 1 minute. But without using this, one can able to solve. So in last session, we have seen the following statement, namely, dAx equal to 0 if and only if x belongs to a closure. Okay. Now, in our question, A was Q, correct? And Q closure equal to R, and the point was given lies inside R, which belongs to A closure. So directly we can use this, and we know to conclude that D of. So this also directly tells that D of QX equal to 0. Okay, so that is the another process. Of course, it is a trick rather than a process. Okay. Okay. So now 1 minute. So let me open the next question. Okay. So, okay, so we have defined this notion of distance between two subsets of, what is that one? This is the notion of distance between two subsets. Okay. Now there are some few questions, so let's try to figure this out. Also, one more thing I should mention is that the link I have shared in the chat box. There, this type of questions are given as a true false type question. Okay, so you can in the free time you can try to look at those questions, and also I put the definitions, and I mean I put the necessary definitions in that site also. Okay, so there you can try to solve those 3 4 questions. I shall try to update with new questions in that site daily basis. Okay, so that will be good practice for you. And one more thing also, if you have any question or doubt regarding this session or in those questions that has posted on the website, if you have any doubt there also, you can put it on the comment box. So that either if it is possible for me to reply on the comment itself, I will reply, or else I will reply in the upcoming live session. Okay. So okay. So now let's start the next question. Sorry, I should make it large. Okay. Okay. So question is that suppose A is equal to set of rationals, B is equal to set of irrationals. Question is find D of A comma B. So you have one. Yeah. You have A is equal to set of rationals, B is equal to irrationals. Now we need to figure out distance only using the definition. Okay. And what is the what is the definition of distance between two subsets? It is nothing but the infimum of all possible distances. Okay. So now try to figure out the infimum of all possible distances between a set of rationals and a set of irrationals. Okay. First, try to figure it about yourself. Okay. Okay. Correct. Zero is correct answer, right? So can you explain?
Like the above result, we used d of a comma x is 0 if and only if x belongs to a closure.
Hmm.
Here, a closure means both in rationals and irrationals, closure is equal to R.
Yes.
Hence, if we take d of q comma x, x belongs to irrationals, then
Hmm.
since x is in irrational closure, which is x belongs to the reals, which
Hmm.
implies d of q comma x equal to 0. Similarly, if we take x belongs to q and distance of x comma r minus q is also equal to 0. Can we tell that?
Yes, your
I
argument is
I
correct,
solved in
but
like 2 steps.
that's correct. Very good. Your argument is absolutely correct. I mean, argument is correct, but there is a mathematical error. Let me point out for you. So initially you have used the fact that d of ax equal to 0 if and only if x belongs to a closure. This fact you have used, correct?
Yes, sir.
So point is that d of a comma b, this is defined as infimum of distance between points of a comma b, correct? It is not of the form, it is not of the form infimum of d of a comma x, correct? It is not like that, correct? So directly you cannot use this process. I mean, directly you cannot use the fact that d of x equal to 0 if and only if x goes to closer. Am I right? I do understand what I'm trying to say.
Yes, sir.
Yeah. So so that's why directly mathematically you cannot use this process or use that fact. Okay. So for that you need to prove it directly. So try out. So whatever you said is correct. Absolutely correct. Answer will be 0. Your intuition is also correct. But try to make it mathematical. So think about it and let me know. And whatever the fact you have used, so instead of directly using this fact d of x equal to 0 if and only if x closure, you can break down this fact in order to show that d of ab is equal to 0 directly. Okay, so try to figure it out. I'm waiting. Let me know when you're done. Okay, okay. So let me explain. Okay. Mm, so suppose you can assume that d of a comma b is equal to r, which is greater than 0. Okay. You can assume this real number can be rational, can be irrational, but it should not be our point of concern. Okay. So now, so since distance is equal to r, this means what? This means this r is nothing but infimum of all possible distances between rationals and irrationals by definition, correct? So this means what? This means what? This means if we choose any two arbitrary points, any two arbitrary rational point and any arbitrary irrational point, their distance will always be less than or equal to r, correct? So this implies distance between r1 and r2 will always be greater than r for any r1 belongs to q and r2 belongs to r minus q. Why? Because r is real, because little r is the infimum of the distances, correct? So now choose some r1 and fix it. Wait. Okay, so now we are choosing some r1 and fix it. Okay, so now we are same way we can consider a ball of radius r, and inside the ball we can find out any irrational number from r minus q so that their distances is less than r, correct? So this is making the contradiction of the fact that r is that little r, this little r is the infimum of all possible distances. So this implies that d of this implies that d of q and r minus q is equal to 0. So this is the argument. Are you able to understand? So whatever you said is correct, but that fact cannot directly be used. So so the process that I explained only in this way you need to explain in exam also. I mean, so that's why you need to also keep in mind regarding the mathematical correctness of some argument. Are you able to understand? Okay, okay. So one. So now, okay. So now the following question. The question is that uh, suppose A be the rectangular hyperbola, all this xy such that xy equal to 1, and B be the xy such that xy equal to 0. Now the question is find d of AB. So there are two questions. First question is if all those xy such that xy is equal to 1, and second subset is all those point xy that xy equal to 0. Now the question is find d of AB. So first, so anybody can tell me that first set capital A is xy equal to 1. How this looks like? I mean, what is the graph of this? So what is the graph of this? Anybody? Correct. So yeah, whatever she said is correct. So this is rectangle first and third quadrant. So now, at least so you have some graphical representation of A and B. Now try to figure out distance between A and B. So of course, in order to figure out this question, you need to have a little understanding of the given subspaces. So now try to figure out the possible distance. I mean, try to figure out the distance between these two subsets. Think about it. Now it should not be difficult. So, anybody is getting any kind of guess what will be the distances? First, you need to guess, then only you can solve it at least, correct? Without guessing, you will be unable to solve. So now you need to find the distance between these two. So, what will be possible distances? Any guess or any idea? Okay, so let me open the chat box here first. Xy goes to infinity to a points of A near to the points. Yeah, correct. So, yeah, so your argument is correct. So, but yeah, very, very good. But how to um, prove it mathematically? Okay, okay, for okay. So let me explain it mathematically. Okay, So kindly wait a minute, please. First. Okay. So, so in order to show, suppose now forward this question. Suppose let S be some set. Okay. So S be some set of real line, and infimum of S is some little s. So infimum is this thing. This is equivalent of saying is that uh, for any epsilon greater than 0, there exists S prime belongs to S such that uh, S prime less than S, sorry, such that S, what happened? S less than S prime less than S plus epsilon, correct? So this everybody you have seen in real analysis, right? So this means what? If you have some set infimum, then if you go to very amount of steps in the right side, then you will get a point which is bigger than that infimum. It is by definition infimum. Okay. Now we are going to use this fact here, correct? Okay. So in order to show d of AB equal to 0, what we need to show? So to show d of AB equal to 0, we need to show for any epsilon greater than 0, there exists A belongs to A and B belongs to B such that 0 less than d of AB less than epsilon. Now the point is this side is always true. We only need to show for any epsilon we're able to find A and B such that d of AB is less than epsilon. Correct? Till now, are you able to understand what I'm trying to say?
Yes, sir.
Okay. So now, so you have said epsilon. Now you need to find the 2 points. So now can you please guess for any given epsilon, what are the points you can take such that the distance between those 2 points will be less than epsilon? Now try to think about it. Let me also think. Yeah, try to think about what will be the points of A and B whose distance is less than epsilon. Are you able to find out those 2 points? Are you able to figure out those 2 points of A and B? Okay. So, so look, the point is it is very easy. Okay. So let me write it down for you. So, so, sorry. So take A is equal to epsilon comma 1 by epsilon. So this point already belongs to A. Okay. Sorry. And take B belongs to epsilon comma 0. Okay. So, so what will be the distance between A and B? So their distance between A and B is 1 by epsilon, correct? And anyway, 1 by epsilon, this is less than epsilon, correct? So, so this is less than epsilon if epsilon is greater than 1, okay? So this process hold if epsilon greater than 1. And if epsilon less than, sorry, if epsilon less than 1, we can take B to be equal to, um, um, yeah, you can take B to be equal to 1 by epsilon comma 0 and 8 and the point A to be equal to 1 by epsilon comma epsilon. Then d of AB, this is equal to epsilon, which is less than 1 by epsilon, if epsilon is less than 1. So in any situation, we can say that their distance is always less than epsilon. So that is what we are trying to say. Are you able to understand how to choose this point? The point is that you can directly choose the point depending on the value of epsilon. Understand? Okay. Okay. So let's move to the next question. 1 minute, please. Okay. 1 minute. So on the last session, we have seen um, definition of compactness. Okay. So compact means what? So compact means every open cover will have a finite subcoverage. That is what by mean of compactness, correct? So now, uh, okay, so every open cover will have a finite subcoverage. So in metric space, those who have studied metrics at least, they must have seen that in compact metric space, compact metric in metric space, compact subspace will be closed. Okay? But in arbitrary topological spaces, this is not true. When it is true, when the given space is Hausdorff, then the compact subspace of the Hausdorff space is closed. Okay. So, try to show the following. So compact subspace of Hausdorff space is closed. Compact subspace of a Hausdorff space is closed. Of course, where X, so suppose X tau be a topological space. Compact subspace Hausdorff space is closed. How you can try to prove? Of course, you need to explore the definitions of the compactness, Hausdorffness. So, 1 minute. So let me first give you some idea or hint how to solve it. Okay. So suppose this is our x, and suppose these are compact stars. Okay. We need to show A is closed, correct? So what we can show, we can show that x minus A is open. The same as showing that x minus A is open. Okay, equivalently. So what we can do, we can take some point x, and that around that point we need to find open ball containing, we need to find open ball which does not intersect capital A, correct? Now how one can achieve this? Firstly, the given space is Hausdorff, correct? So for if we choose each point of A, there is so we will find an open ball around A and an open ball around little x such that their intersection are disjoint. So for each point in capital A, we are able to get such balls, which I mean, sorry, such open sets such that these open set intersects the ball X, the open sets and the open set around X. So now, so there exist many open sets around X. Okay. Now, since A is compact, so A can be covered by finite number of such open sets. Okay. Now, if we take the union of all those open sets, then those open sets will contain capital A. And if we take the intersection of all those open sets, then this intersection will contain only this point single x. I mean, sorry, this intersection will contain x, and this intersection will be disjoint from capital A, at least visually. So in this way, we can able to separate the point x with our open set, which is disjoint from the set capital A. So now try to, so this was my hint. Now try to figure out how to do it mathematically, or first try to understand what was my argument. Okay, first try to think and figure out what is my argument. Okay, please think about it. I shall be back after a few minutes. Well, are you able to figure this out? How to show that this will be closed? It is not difficult. Anybody, are you able to figure this out? How to approach it mathematically? Okay. So let me write down mathematically first. Okay. So okay. So okay. So one. Hmm. So 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 since so what do we need to show? We need to show that x minus a is open. This is what we need to show, correct? So what we're doing, we are choosing a point x naught outside A. Okay, that is possible. I mean, sorry, that's what we are trying to show. So we are assuming that there is at least one point. Right. Now, by Hausdorffness, For each A belongs to A, there exists UA, which is an open set around A, and VA, which is an open set around X, such that UA intersection VA empty. Correct? So till now, is everything correct? Till now, are you able to understand, follow? So, so what are you doing is the following. So by Hausdorffness, for each A belongs to A, we are able to get some, yeah, for, sorry, what happened? Yes, for each A belongs to, we are able to get some open ball around X around A, which are disjoint from each other. Okay. Now, what we shall do is the following. So UA intersection VA is equal to empty. Okay. So now we have UA, which is an, this is an open cover for A, because for each A belongs to, you are getting such open set. Now A is given to be compact. Okay. So this implies what? This implies this open cover admits a finite subcover. Correct? Now, what we are doing is the following. So, since admits a finite subcover, so that covered, suppose that covered is U of A1 dot 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 U of AN. Okay. So this covers this whole set capital A. Okay. Now, so correspondingly, we have V of A1 dot 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 V of N, and keep in mind that each of this contains little x. Okay. Now, what we are doing, we are doing the following. Take V to be intersection of VAI, I is equal to 1 to n. This intersection of course contain x because each of x is contained VI, and observe claim is that V intersection A is equal to empty. Why? Because if V intersection is non-empty, and observe that this A is nothing but union of UAI, I is equal to 1 to n. If this intersection is non-empty, this implies what? This implies there exists T belongs to V intersection UAI for some I. Okay. And this V is what? V is intersection of VAI. So this implies what? This implies this T belongs to VAI intersection UAI, which is a contradiction, correct? Am I right? So this is the argument. So are you able to understand or are you able to catch up this argument? Let me know. Are you able to catch up the argument? Let me know. Okay. Okay. So, yeah, okay. So this is the thing. So now, so look, so in this question, what is the main fact is that in topological space, compactness does not necessarily implies closeness. For that, Hausdorffness is necessary. Okay. So now, try to find out. I mean, try to think about it now. Okay. Question is that example of a compact space which is not closed. So now try or think about it now. To provide an example of a compact space, I mean the compact file space of some topological space which is not closed. Try to figure out. Think about it and let me know. I mean, so of course you need to consider non-Hausdorff topological space. Try to think about it. Try to come up with some example. If you're done, then please let me know. So, so Kofana topology compact, but house draft and not closed. Uh, no, no, look, the point is that so whenever you are saying something is closed, correct? It's closed in the closed in the bigger space, right? Now, if you take the full cofinite topological space, then of course the full space is closed in itself, correct? So there you cannot mm, give the example, correct? So I mean, so tell me mathematically correct statement. Do you understand my point? Whenever you are saying cofinite topology, so this means the cofinite topological space, big space is always closed, correct? I mean, X is closed in itself, right? So there it is not making any sense. So exactly what will be the proper mathematical statement? I understand your counter example, that is correct, but tell me the proper mathematical statement. Tell me the proper mathematical statement only. So mathematical correct statement should be as follows. So mathematical correct statement should be as follows. So you are considering X and cofinite topological spaces. You are choosing any subspace of X. Okay. So now this is compact. Okay, but not closed. Why? So there are two. So this thing you also need to verify, correct? You need to provide example of a compact space which is not closed. So as for your example, if you modify it mathematically, so we are choosing some subspace A of capital X that is compact. But now we need to argue that that is not closed. Why? I mean, why closed subspace will not be closed? So of course there is some modification needed, correct? So what will be that modification? I mean, any subspace of cofinite topology is of course compact, but it does not mean that but it does not mean that it is not closed, correct? So you need to choose some subspace which is not closed. So what will be that? Think about it. Okay, so okay. So first of all, if you choose any arbitrary subspace with cofinite topology, so it will be compact. So there is no doubt in it. So you need to find out some set, some subspace which is not closed. Correct. So in cofinite topology, what are the open sets? 1 minute, please. I shall be back after 2 minutes. Sorry. Okay. So 1 minute, please. Okay. So so um so we need to choose. So okay. So now tell me in cofinite topology, what are the open subspaces? So in cofinite topology, what are the open sets? Open sets are all those open sets are what? All those U such that x minus U finite. So by definition, is the open sets, correct? So this implies what? This implies open sets are of the form x minus f is a finite set, correct? So so x minus a finite set, there is open set. So this implies what? So this tells that any finite set is closed in cofinite space, correct? So this implies what? This implies if you choose some subset of capital X which is not finite, so that is not closed. So this tells what? This tells finite subset is closed. But this does not mean that closed implies finite in general. But any closed set is also finite. Why? Because 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 if you consider its complement, that will be open. Complement is open means what? Complement open means the complement is complement open means that x minus, so if you take f to be the closed set, close this implies f complement open. This implies x minus f complement finite. X minus f complement nothing but f. Okay, so this is the argument. Are you able to understand? Any finite set which is closed in cofinite, any finite subset is closed in cofinite set, and any closed set is also finite. So this is the argument. So if you choose any subset of capital cofinite topological space which is not finite, so that will automatically be not closed. Are you able to understand my argument? Let me know. Are you able to understand my argument? Okay. Okay. So now, okay. So now the next question. So 1 minute, please. Okay. So 1 minute. One minute, please. Let me find out the questions itself. Okay. So there are few basic facts that we need to recall also. So first fact is that now since these facts are not difficult, it's actually very easy from definition. So I'm not writing those proofs. I'm just only going to mention those facts. Okay. So the first fact is that image of a compact set under a continuous map is compact. So this is the first fact. So let me know. Are you aware of this fact? That is that is if f is a map from x to y and f is continuous, and if x compact, so this will implies f of x compact. Are you aware of this fact? Okay. So I'm not going to. Okay. Thank you. So I'm not going to prove this fact anyway. So okay. So now the next fact is the following. 1 minute, please. Yeah. So the next fact is following. Let f x to y be bijective continuous function if x is continuous, if x is compact and y Hausdorff, then f is homeomorph. Are you aware of this fact? That is, there you have some bijective function, domain compact, codomain Hausdorff. Then the given bijective function will be homeomorphism. Yeah, it's a very strong fact. But are you aware of this fact? Okay. Okay. So, how to prove this? 1 minute. Okay. So first, I shall give hint. Okay. So, so look. So if is homeomorphism means what you need to homeomorphism you need to show that if is that is to show if continuous and if inverse continuous. Okay. And if inverse continuous, it is equivalent to showing that f is open map or f is closed map. Okay. Now hint is try to show f is closed map. Okay. Try to show f is closed map. So please try it by yourself by those theorems which we have already seen, and please try to figure it out. I shall be back after a few minutes. Okay. Please try to think and try to solve it. Okay, let me know. Are you able to figure this out? Are you able to figure this out?
Yes, sir.
Yeah, okay. Can you please?
Given f from x to y is continuous bijection,
Yeah,
and x is compact implies f of x is compact by the
correct,
previous result.
correct.
Now f of x is compact, y is Hausdorff, and f of x can be the subspace of y,
Yes,
which
correct.
implies f of x is closed.
Uh, Correct. Right. Very good. Now, wait. What we have showed, you have proved that f of x is closed, correct? But what we need to show, you need to show that f is a closed map, right? So closed map means what? You need to choose some arbitrary closed set from capital X, and you need to show that if so call it f. Suppose f be an arbitrary closed set in capital X, and then you need to show that f of little f of capital F is closed in Y. So then only you are able to show that f is a closed map. Am I right? What you have showed is that capital X you choose, and you choose that f of capital X is closed. But we need to check if of arbitrary closed set is closed for any given closed subset f of x. Are you able to understand my point?
Yes, sir.
Yeah. So whatever the argument you told, it is correct. Just you need to replace the closed sets accordingly. So think about it and let me know what will be the modified or correct argument. So please think about and let me know. So are you able to figure out the adjustments?
We need to take a closed subset of X.
Okay. Yes, of course. Then you need to do a closed subset of x. Then what? So 1 minute, let me write it down. So let f subset of x be closed. Okay. Then
Then capital F is compact in X, which implies f of f is compact in Y also.
why capital F compact?
Compact subspace of a compact set is compact. Isn't that true?
Yes. Sorry. What you have said? Compact subspace of?
I'm sorry. Closed subset of a compact space is compact.
Correct. So F is compact. So this implies F of F is compact in Y. So this implies F of F closed. Yeah, that's correct. Good. Okay. So now, okay. So one thing I should mention is that try to remember this particular question, okay? Because solving problems, this question is very much helpful in the following situation where the left side is compact, right side house drop. Then a given map is closed map. So this fact is useful many times. Okay. So so do you know the fact that product of compact space is compact? Do you know the fact that product of compact space is compact? Okay. Okay, so I'm not going to do that. And so okay, so now tell me, do you know anything about finite intersection property? So let me write it down. It is finite intersection property. Do you so have you heard about it before? Okay. So let me write down the finite intersection property. Okay. So one let me 1 minute. One minute, please. Oh, what happened? That's what I'm trying to figure out. Okay. Okay. So hmm. So finite intersection property. What? So this means that. mm, so let X be a topological space. Okay. And then a collection C of closed subspace of X said to have finite intersection property if for any finite subcollection C1, C2, Cn of C, the intersection is non-empty. So this is the argument. Okay. So suppose X be a topological space. Okay. Then a collection C of closed subspace of X is said to have finite intersection property if for any finite subcollection C1, C2, Cn of C has non-intersection. Okay. So, um, so this means, so I mean, the point is, so basically, if you consider any finite subcollection C, their intersection will not. Okay. So there is nothing to explain more. Now, there is a fact which will detect the compactness of a given space in terms of this finite intersection property. Okay, and this finite intersection property, in short, people says FIP. Okay, so now the theorem is the theorem of question. What you can say, that's okay. Theorem is that um, yeah, X is compact if and only if every collection C of closed sets in X having finite intersection property has non-named intersection. That is intersection C. C belongs to C. This is non-empty. Okay. So now, uh, what does this statement tell? This tells that sub X is compact if and only if you choose any collection C of closed subsets of Nx and such that those collection have finite intersection property, then if you take the arbitrary intersection of all elements of C, the intersection will be non-empty. So this is what this question tells. So try to figure this out using the definitions only. Okay, nothing more than definition is needed to be used. So please try to solve it by yourself. I shall be back in a few minutes. So are you able to figure out how to approach this problem? Anybody? Okay. So let me explain. So the argument goes as follows. So what we need to show? We need to show X is compact if and only if every subset C of closed subset having if F has non-intersection. Correct. So for that, what I need to do? So sorry, let X compact. Okay, let X compact, and let C be collection of closed sets having FIB. We need to show what? We need to show intersection C belong to say non-empty. This is what we need to show. Correct. Right. So 1 minute. What happened? So what we need to show is the following. So this is what we need to show, correct? So now one can use the contractor method. Suppose intersection C belongs to C, empty. Suppose. So this implies what? This implies union of C complement C belongs to whole of X. Sorry, sorry. So this implies this collection of complement of C is an open cover of X. Now it is given that X compact. So this open cover has a finite subcover, correct? So let the finite subcover be X minus C1 dot X minus Cn, correct? So this means what? Union of X minus I is equal to 1 to n. This thing is equal to whole of X. But this implies what? Intersection I is equal to 1 to n, Ci, this thing equal to empty. But this is a contradiction. Why? Because we have initially assumed that C is a collection of closed subspace such that it has finite property, but the intersection of these Ci's is empty. So this is contradicting the fact that capital C collection of capital C has a finite intersection property. That's why. So this tells what? This tells that this intersection C belongs to C. This one, excuse me, this intersection has to be true. Are you understand my argument? Okay, 1 minute. Okay, so this is one side. So for reversal, what we need to show? For reversal, we need to show that every collection satisfying their property, we need to show that X is compact. Now, can you please try to yourself? So for that, what? So for the opposite side, we need to start with some open cover of X, and open covers it covers X. So complement of this open cover will be a collection of closed sets. Now we need to show that that complement of the open cover will have the finite intersection property. And then you can show that the intersection is empty or not, that you can use. The point is that you can consider open cover, and using the open cover you can consider as complement, and then you can come up with the collection of closed subsets of X. Now please try to figure it by yourself. I mean the process is same. There is nothing new actually. Or you can try it in your home also. Okay, so okay, so you can try it in home, and you can let me know the next day itself. Okay, or you can. So also one thing I am mentioning again that in the chat box. 1 minute. I have pasted one link in the chat box. Just copy the paste and keep it with yourself. So there I posted all the three questions regarding the distance function initially. And so if you have doubt in those, you can comment on that. So I can directly come and reply if possible, or else I can explain that in the next session. Okay. Or you can post your questions there also. Okay. So yeah. So that is a thing I want to mention. So yeah. So, let's stop today here. And this last question that for the reverse side, you please try to solve it yourself. If not, then please let me in the next session. I shall do it for you. Okay. So now I am leaving the call.